I just breadboarded the D flip-flop. It's a 74 LS74, and we're going to be using the dip switch to emulate the clock and the data 5 volts going in to my D1 and my clock pins on the flip-flop chip. My outputs are Q and Q naught. So basically what we're going to do here is, I'm going to have to get this thing sideways so I can operate the switches. So basically what's going to be happening here is when we get a change, this is actually this pin here, this black wire here is my data, and the red pin, the red wire is going to my clock. So nothing's going to happen until the clock actually triggers. So my clock is going to go from 0 volts to 5 volts, and that's what's going to give me the output if we have a change on the data. So if there's no change on the data, we won't get any change. So you can see, here's my clock, no change, because we didn't have a change on the input data. So we're going to change the input data. And there we go. We had a change. And then, so no change, no change, no change, no change. And we're going to get another change. We're going to a logic low. There's Q naught. No change, no change, no change. We're going to get, we're going to go back to a logic high. There's Q out high, positive. No change, no change. We're going to get 3 or 4 pulses here in between a clock trigger. So we're going to go 1, 2, 3, 4. No change, no change, no change. So everything is dependent on the data coming in, but nothing happens until the clock goes from either a digital high to a digital low. So it's a edge trigger clock D flip-flop.